Hey, welcome back everyone. We are now on our second video for this week under the topic linear inequality in two variables. So let us proceed. Okay, on the first part, we were introduced with the term inequality. We were given a list of symbols that we could use. So we have the not equal sign, we have less than or equal to, greater than, and greater than or equal to. Let us take this example. If we have x is equal to 1 or x equals 1, then we have a specific value for x, which is of course 1, since x is equal to 1. But what if we were given x is greater than 1? Then we have multiple possible values for x. So if we're going to represent that on a number line, okay, so we will mark the number 1 or positive 1. Okay, we used a hollow circle because 1 is not included. Okay, since it's greater than 1, so we will draw an arrow pointing to the right. Yeah, that's correct. So how about if it's less than? So we will draw an arrow to the opposite direction. So again, we will still begin on number 1, but we're going to use a hollow circle since 1 is not included. And the arrow will be pointing to the left. But if the given is x is is less than or equal to 1, then we will mark x is equal to 1 first. Okay, so we will shade positive 1 because 1 is included, because x can be equal to 1 or it could be less than 1. So we would represent x is less than 1 with an arrow pointing to the left. Okay, so here let us differentiate linear equation with linear inequality. So as you can see, we have here two given. They're basically the same, but they have different symbols or different signs. For the equation, of course, we're using the equal sign. For inequality, we have several options, but on our given, we have less than or equal to. Okay, let us concentrate first on this side. So this line represents this equation. Okay, we've already discussed this on the previous video. We said that every point along this line, okay, would satisfy this equation. So for example, we have here -2, 0, we have 0, 3, we have another point here that's 9/2, 1. Okay, all these points, okay, if we substitute the x and y values of the ordered pair to this equation, it will have the result will be true or correct. Okay, all these points would satisfy this equation. Okay, so if we go on this other side, you must first understand that this inequality less than or equal to means that y can be equal to 3/2x plus 3, or y could be less than 3/2x plus 3. So if you will notice, this part is the same as this one. That is why we are representing it with the same line. So we already have the representation for y is equal to 3/2x plus 3. All we have to do is represent this part. What is y? Less than 3/2x plus 3. At first glance, since it's y less than, so if y is the movement upward or downward, since it's along the y-axis, since it's less than, so this should be the lower half. But we need to be sure, and in order to do that, we could take a point, okay, and test it. Okay, this will be our testing point. When we say test, then we take the ordered pair and substitute it to our inequality. So our x is 1, our y is 1. So let us substitute it with this inequality. Okay, change x to 1, change y to 1. Okay, and let us solve. So 3 over 2 times 1 is 3 over 2. I've changed 3 into a fraction form. So 3 is also the same as 6 over 2. Because 6 divided by 2 is 3. Okay, the reason we changed it to fraction is for us to easily add these two numbers. So 3 plus 6 is 9, so we have 9 over 2. So as you can see, this is correct, right? 1 is less than 9 over 2. If we are going to change 9 over 2 into decimal form, that is 4.5. And 1 is definitely less than 4.5. Okay, so since this is correct, we have determined that this region or this area would satisfy, all the points in this region would satisfy our given inequality. Okay, so see the difference? In our equation, our representation is simply a line. But in the representation of our inequality, other than the line, we have an entire region. Okay, so there are multiple points that could satisfy our inequality. Okay, so I just want to point out, because some are asking, some are somehow confused by the given in our learning task. Okay, so if we're going to look at our Cartesian plane, always look for the two lines, okay? Our vertical line and our horizontal line. This will be our x-axis and this will be our y-axis. So it's a little confusing because they've written the numbers a little too far from our line. So some are, Ma'am, is this the line? No, these are just the label. These are just the numbers to label our number line. Okay? And how about this one? We have another vertical line here. This is actually our given line. Okay, this is not our y-axis. Our y-axis is this one, the one that passes through 0, 0, or our point of our origin, point of origin. Okay, so here is a little better drawing of our Cartesian plane. Okay, and it is properly labeled x and y, so you won't be confused. So I'll give a different line, almost similar to this one. I will not give exactly the same one as an example, so that you could try solving this one on your own. Okay, so here we have a vertical line. This is our given. As you can see, it passes through -2 on our x-axis. Therefore, our equation is x is equal to -2. Okay. Why is this so? As you can see, each and every time, x is always -2, no matter what the value of our y. If our y is 0, x is -2. If our y is +7, x is still -2. If our y is -9, our x is also -2. So this is our equation to represent this line. It's simply x is equal to -2. No matter the value of our y, x will remain -2. That is why our line is a vertical line. Okay. So what if our inequality is x is greater than or equal to -2? Okay, since here we have equal to -2 also, so we will use the same line. Okay, but this is just a representation for the part x is equal to -2. Okay, now we need to represent x is greater than -2. Since this is x, the greater than would be this part on the region on the right side. Okay, so we could show this by shading this area or this region. Okay, so this is the representation of our inequality x is greater than or equal to negative 2. So what if it's only x is greater than negative 2? We will still use the line x is equal to negative 2 as reference, only as reference. So we need to draw it as a broken line, okay? Because x is equal to negative 2 is not actually included. So the values or the points along this line would not satisfy this equation. So now we just have to represent x is greater than negative 2, which is this region, right? The same as this one. So we could also draw it this way. We could draw arrows. Okay? So it depends what you prefer. If you prefer to shade it this way or if you prefer drawing arrows. Okay? So there you go. So this ends our second video. On the third video, we will show you how to graph inequalities. Okay, again, thank you very much for watching, and hopefully this could help you answer your learning task number 1. Thank you very much. Stay safe and bye-bye.